Okay, so I hope you are not watching this unless you have already tried the problems, because I'm going to go super fast, and so it's just for you to check to see if you know what's happening. Now, up at the top, those two functions that I have right here and right here, those are going to be used for most of this first page that you took a picture of. So think of this as your number one. It wants the domain of f of g of x. So when you see this notation, it's to plug the back one into the front. So g is getting plugged into f, which means that my function is going to be the square root of, instead of x, it's going to be all of g. Okay, now this is what f of g looks like, but it wants the domain of this. And remember, with domain, if it's a radical or a fraction, you have to be really careful. If it's a radical, you're supposed to take whatever is underneath the radical and make sure that it's greater than or equal to 0, because if it's not, it's imaginary. So now what do? Well, once you write that out, you just solve for x. So just move the 5 to the other side and then divide off the 2. So the answer to this is domain is that x has to be greater than or equal to 5/2. Okay. All right, the next one says f plus g of x. Well, with f plus g, you are literally just adding the two functions. So it's going to be the square root of x plus 2x minus 5. Now from here, this has an x back here, so I get to leave the x's in the problem, and I can't combine anything because there are no like terms. So like, I'm finished. Like, this is it. You just write it out and you're done, because nothing can get put together. The next one says g divided by f, so I'm going to write out g divided by f. Notice it's still an x back here, so I get to leave the x as the variable. So g on top and f on the bottom. Now with these problems, you do have to be careful, because if it's a fraction, you've got to let your teacher know what x is not allowed to be. And what you do is you just look at your denominator and ask yourself, okay, what would x be that would make the denominator 0? Because that would be really bad, right? Well, in this case, if x were 0, then the square root of 0 is 0, and this would be very bad. So I just need to put a restriction out to the side. So if it was more difficult than this, how would you solve it? Well, you would just take your denominator and set it equal to 0 and then solve. Just move some stuff around and get the x by itself. Okay? But this is very important back here. Alright, the next one, it says g with a negative 1 of x. Well, you should know that that means inverse. So this wants the inverse of g. So g looks like this, right? So g, this is the actual g. Now to do an inverse, you may remember you're supposed to switch the x and the y. So here's me doing the switch. And now you're not done. You need to get y by itself. So I'm going to add 5 to both sides, and then I'm going to divide by 2. And when I do that, this equation that's left over is my answer. This is it. So that's how you could write your final answer. Okay, the next one wants the inverse of f. So same thing. The original f looks like this. So what we have to do is switch the x and the y. And now I have to try to get y by itself. Well, there's a square root over it, and I know that seems like a problem, but we can just square both sides, and that'll get rid of that square root. And so y is just x squared. So that's it. Nothing more complicated than that, okay? The next one looks fun. Okay, g of f of g of 3. Okay, since there's a 3 in the back, I'm going to start with that, because this is telling me instead of x's, I get to plug in a 3. Well, where do you plug in the 3 first? Well, you plug it into g first, because you're working back to front. So first I'm going to find g of 3, and that just means plug a 3 into that equation. So 2x minus 5 becomes 2 times 3 minus 5, and I'm getting a 1. So like all of this is now a 1, because I just figured it out. Now what do? Well, now I take that 1 and I plug it into the thing in front of it, which is f. So if f is supposed to be the square root of x, it's now the square root of 1, because I'm just plugging that in. So what is the square root of 1? Well, that's a 1. So now this is all gone, and the answer to this is also a 1. That is a coincidence. Don't think that always happens, okay? And now what? Well, the very last thing, what is g of 1? So I need to take that 1 and plug it into the final function that's listed in the front. And when I do that, I get -3, and that's my final answer. So those can be kind of fun as long as you work back to front, and just be careful. Notice I take a lot of notes. I do a lot of scratching out. I'm not doing this for your benefit. This is how I do these problems, okay? All right, now it wants the range of this madness. Okay, so first of all, I've done a fraction of g over f, but then I want the inverse of that. Well, if you write all of this out, it's going to look ridiculous. And then if you switch the x's and the y's, I mean, you're going to get stuck. What you need to know is that if you are asked about the range of an inverse, that is the same as the domain of the original. And what do I mean by original? Well, in this case, the original is f over g of x. So basically, you take this without the inverse symbol, and you're just finding the other thing. So the range of the inverse is the same as the domain of the non-inverse of the original. And so if I'm going to approach it this way, because f over g is really quick and easy for me to write. It just looks like that, okay? And so if I'm looking at that and I need the domain of this, then I just have to be careful because it's a fraction. And how do you deal with a fraction and domain? Well, you take the denominator and you set it not equal to 0, and you solve. So let me move that 5 to the other side. Let me divide by the 2. So here's my domain. X cannot equal 5/2. If you want to be picky, I mean, you could do it two ways. You could say x is part of all real numbers except x can't equal 5/2. That's called set notation. Or your teacher might have shown you interval notation, where you would do this whole like -infinity to 5/2 union with 5/2 to positive infinity. So I'm going to put a big fat or. Either of those is fine. I'm not sure how they want you to write it, but this, or even sometimes this are acceptable. Okay, cool. So, oh, you know what I did wrong actually? This wants to know the range, and I just did everything in terms of x. Okay, I may need to switch that to a y. Let me see. Yeah. Goo. Okay, so sorry, I'm going to retract just a bit. We found the domain of the original, but we have to be careful because if it's the... Oh, you know what? We're fine. We can do it just like this. I'm sorry. I'm going to shut up. We're good. We're good. Okay, now the last one, which has an inverse. Okay, so A, B, or C, one of these is going to have an inverse. Now, how are you going to tell? An inverse has to be a one-to-one function. And a one-to-one function means that each x goes to exactly one y. It also means that you pass the horizontal line test. So, for instance, when I look at this, I know you're used to doing the vertical line test. Yay, and that passes the vertical line test. However, one-to-one means that you have to pass the horizontal line test. And this function fails it badly because if I draw a horizontal line here, I cross it 3 times. So since it fails the horizontal line test, it is not one-to-one, therefore it does not have an inverse, okay? Over here, look at all my x's. Well, each x is, there are 4 different x's, yay, and they are going to y's, but look at these two. These two x's go to the same y, which means it is not one-to-one. Okay, so this is also has no inverse. So, you know, reasoning goes to show that this last one probably is the answer, and it definitely is. If you wanted to check that, you could easily look at a graph of this on your calculator, and it's going to look something like that, which this graph passes both the horizontal line test and the vertical line test, okay? And so therefore, since it passes, I know it looks questionable there, but it is still growing ever so slightly, so when you do the horizontal line test, you'll just be crossing it at one point each time, okay? So this is going to be my answer. All right, next page. The next page is a lot like your older stuff, but it also has transformations. So on a question like this one, I recommend that you draw it as you read it, then try to come up with an equation, okay? Please, please draw it. So we have a function that's a parabola, okay, which means it's an x squared, and it's going to be shifted to the left 2. So I've got a parabola left 2, down 1, so it looks something like this, okay, and then it's reflected across the x-axis. So if I reflect this picture across the x-axis, it's going to look like this. Once I have the final picture of what they want, now I'm going to write the equation, okay? Well, if it's reflected, it needs a negative, right? If it is moved to the left 2, it needs a plus 2. And my parent was a squared, so I better have that squared right there. And then the vertex of this is shifted up 1. So it looks like this. Okay, now write the equation for this fella. Well, this looks like a square root function. And normally they look like this, right? So what happened to this to make it go here? Well, it was definitely reflected. And which way was it reflected? Well, it looks like it was reflected down and over. So if something's reflected down and over, there's a negative on the outside and there's a negative on the inside. Okay? Now what else has happened to it? Well, this point has gone to the left. It looks like 2. So I'm going to say x plus 2 again. And then it looks like it's been shifted up 3. Yeah, that looks about right. So that would be my final answer on that. Okay, back to piecewise functions. Okay, so you're supposed to analyze 3 different x values and find their y's given this piecewise. Remember, you need to figure out based on this number which of these 3 that it fits into, and then that's the equation you're going to plug it into. So 2.1, if I read all of these, 2.1 is greater than 0. So I'm going to plug this one into the first one, okay? And when I do that, I get 2.1 minus 1, which is 1.1. Now, what does this symbol mean? Well, this was that function that tells you to round down to the nearest integer. So 1.1 rounds down to 1. And that would be my answer for that one. Let me switch colors so that you can see where I'm plugging in. Okay, f of 0. Now, if we're plugging in exactly 0, I see a 0 here and I see a 0 here. So which one of these equations do I use? Well, I use this one because of that symbol of less than or equal to. So you want to use the 0 that's included with the equal symbol, okay? So I'm going to plug in a 0 right here. 0 squared minus 5. Is negative 5. And then my last one is a negative 1. So how do I do a negative 1? Well, with a negative 1, I need to see which of these 3 it fits into. And same thing, negative 1 shows up twice, but this one has the equals, so I'm going to use the third equation, okay? So I need to plug in my negative 1 right there. So it's the square root of a negative 1, which is the square root of 1, which is 1. And that's how you can do that. Okay, now it's like really old stuff, right? So write the equation of a line that's perpendicular to this through this point. Well, the first thing I need is the slope of this one so that I can find the perpendicular slope. So the slope of this, I'm going to move my stuff around. Okay, so this is the actual equation, and I needed to get it in this form so that I could steal the slope. Now, if this had said parallel, I'm going to keep it as a 2, but it says perpendicular. So with a perpendicular slope, if m is perpendicular, then I need to take that number and make it a negative reciprocal. Remember that? So 2 becomes negative 1/2. Change the sign and do the reciprocal. So this is my slope and this is my point. Well, if I have a slope and I have a point, I can just do point-slope formula. Now, some people write it like this. I have it memorized sort of like this. That way the y is already by itself. So I'm just going to plug in here, here, and here. So my slope is a negative 1/2. My x is a -1, so it's minus a -1 or +1, and then I've got a +4 back here. And that would be my answer. Yay! Alright, and the very last one, find the distance in midpoint given these 2 points. So for the distance formula, you can either use the actual distance formula or you can do the Pythagorean Theorem. I'm a pretty big fan of Pythagorean Theorem because the point 0,4 would be here and the point 714 would be about there. And I usually just draw myself a nice little triangle out of this. And I know that to get from a 4 up to a 14, that's a distance of 10. And on the x-axis, to get from a 0 to a 7, that's a distance of 7. And then I can just do a squared plus b squared equals c squared, and I can finish it out that way. I know you can't see this very well. That's better. Alright, so 49 plus 100 equals c squared. So c equals the square root of 149. Now, does that break down? I don't know. I don't want to do this. I don't think it breaks down. You can try it. I'm going to go with my gut and say that's my final answer. Okay? Now, what about the midpoint? Well, the midpoint formula, I don't really write that down either because a midpoint means you're just averaging these 2 points. So to average something, you add them and divide by 2. Okay, so just think like terms, right? Like I've got 2 x's and I've got 2 y's. So let me just do the x's first. So if I average the x's, I get 0 plus 7 over 2. If I average the y's, I've got 4 plus 14. What is that? 18. 18 over 2 is 9. And that would be my midpoint. All right, hopefully that helps. I tried to go quick. Study this in conjunction with your review sheet and let me know if you guys have any questions. Good luck to you.